Hello, everyone, and welcome back. Mr. Knight is here with you again. For this week, I want to do some organic chemistry. In fact, we're going to focus on 3 homologous series, particularly alkanes, alkenes, and alkynes. But for today's lesson, I am only going to focus on alkanes. And so alkanes are a group of hydrocarbons or organic compounds consisting of only single bonded carbon atoms. Also, I wanted to note that the general formula for alkanes is CnH2n plus 2, where N is the number of carbon atoms. Let's do an example to put the concepts together. And so when we say single bonded carbon atoms, we are talking about that between each carbon, there is a single bond. So between these carbons, we can only see single bonds, a single line. To be hydrocarbon, it means that the compound consists of only carbon and hydrogen. Based on the general formula, CnH2n plus 2, what this means, taking for example, we're seeing 4 carbons here. So therefore means that what we get as a molecule, we get 4 carbons along with 10 hydrogen. So therefore the 4 will multiply by 2, give you 8, plus 2 gives 10. So notice that 3, 2, 5, plus 2 more is 7, plus 3 more hydrogen, that gives you 10. So that's the 3 concepts all together. Single bonded carbon atoms, hydrocarbons contain carbon and hydrogen. And based on the general formula, if we have 4 carbons, we should have 10 hydrogen. All right, now the next concept is how do we name simple alkanes? Now this is based upon 3 things. There is a prefix, a suffix, and then the name. Now let's look at it. Let's draw a table really to demonstrate this. All right, so now the prefix is based up on the number of carbon. So for example, there's 1 carbon, it's meth, 2 carbon is eth, 3 carbon, prop, 4 carbons, but, 5 carbons, pent, 6 carbon, x, 7 carbon, ept, 8 carbon, oct, 9 carbon, non, and 10 carbon, dect. Now the suffix for alkanes is all ane. So the ending of the alkanes is ane. So if we join them together, what we have as the name, we will have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And these are associated with the number of carbon atoms. Now, let's look at the general formula a little bit more. And so just to remind you again, the general formula for alkanes is CnH2n plus 2. Remember, N is the number of carbon. So let's take, for example, if we have 5 carbon atoms, then the number of hydrogen will multiply that by 2 and then add 2 to it. So we should have now C5H12. 5 multiplied by 2 gives 10 plus 2 is 12. And for this compound, it is called pentane. Remember, pent for 5 carbon atoms. Now let's look at the formula for all of these alkanes. And so you remember, based on the general formula, CnH2n plus 2. So for example, let's look at methane first. So going to be CH4. Let's take another example here. Let's jump to hexane. So if it is 6 carbon, then 6 times 2 is 12, plus 2 is 14. So that's 14 H's. Let's look at octane, for example. If the number of carbon is 8, 2 times 8 is 16 plus 2 is 18. Let's look at the last one here, which is decane. And so if it's 10 carbon, then 10 times 2 is 20. 20 plus 2 is 22, so it's 22 H's. Okay, so you could go through the others that I've missed, and you can check them on your own to make sure that you understand the concept of using the general formula. Now let's look at some examples of structural formula for alkanes. And before I jump into this, let me just quickly do a review or quick reminder for you. And what I want to remind you about is that a single carbon atom must consist a maximum of 4 single bonds. In other words, around each carbon, you should see 4 lines. So no matter how you draw a carbon compound, around each carbon must be 4 total lines. But remember, for alkanes, we're only drawing single bonds. And those single bonds are between the carbon atoms. So let's go into it. And so let's draw methane. And remember again, each carbon must have 4 lines. So if it's only 1 carbon, 4 single lines or 4 single bonds. And so each of these single bonds will contain hydrogen because we are looking at hydrocarbon. And so the condensed formula for this structural formula is CH4. Now let's look at another example, ethane, for example. This is 2 carbons. And remember, there is a single line between both carbons. So each of them will share this single bond. So let's look at the first carbon. How many more lines we could put there will be 3. The second carbon can also contain 3 more lines, which means each of these can contain a single hydrogen on each of these single bonds. So therefore, it will be 3 hydrogen around the first carbon. Around the second carbon, there will also be 3 hydrogen. And so in total, we have 6 hydrogen. So to condense this structural formula, what we'll have here, the first carbon contains 3 H's. So therefore, CH3. There is a single bond between the carbon. So this single bond is right here. The second carbon contains 3 hydrogen. So therefore, it is CH3. So this larger structure is called the structural formula. This smaller structure is called the condensed structural formula. And remember, we can also talk about the molecular formula. So the molecular formula will be C2H6. All right, let's jump into another example. Butane, for example. And but means 4 carbons. So therefore, we have 4 carbons, all single bonded together. The first carbon, 3 single bonds, because we already have 1 line there. Around the second carbon, we have 1 line, 2 lines. So therefore, we can only put 2 more lines. The third carbon, again, 2 lines already. We can only put 2 more lines. The last carbon has only 1 line or 1 single bond. So therefore, we could put 3 more. And we could put hydrogen respectively according to these single bonds. And so therefore, the structural formula for butane will look just like this. And so we could condense this to be CH3, single bond to CH2, single bond to CH2, single bond to CH3. So this now is the condensed structural formula. All right, now let's look at some properties of alkanes, which are very important to classify alkanes or to distinguish them from other hydrocarbons. And so one of the property is that alkanes are nonpolar. What this means is that there's no distinct positive and negative charge at the ends of these compounds. So in other words, all around the compound is the same. Alkanes are insoluble in water. And of course, the reason why they're insoluble in water is because they are nonpolar. Water is polar. And remember, nonpolar substances cannot dissolve in polar substances. The third one is that they are colorless. They are the smaller alkanes, they are gases. So anything ranging from 1 carbon to 4 carbon in the alkane series are gases. The larger ones, they are either liquids or solid. So above the 4 carbon will be liquids, then solid. So start a liquid, then go into the more complex one will be solid. But a point to note that the solid alkanes are generally waxy in nature. Another property of alkanes that alkanes are less reactive than alkenes and alkynes, and we'll look at alkenes and alkynes in our upcoming lessons. Alkanes are saturated with hydrogen. The reason for this is because each carbon contains the maximum number of possible hydrogen atoms. Now, another concept I want to look at here now is the types of alkanes that we may have, and alkanes may be classified under 3 groupings. They can be classified as straight chain alkanes, branched alkanes, cyclic or closed chain alkanes. So let's look at an example of each. So taking, for example, the straight chain, which is linear, and this will be called, if you count the number of carbons, you should be able to tell me this one. And if you're thinking butane, you're absolutely correct. For the branched alkanes, if you think about it, it will be in different orientations. And so notice there is a running here, a chain going this way, or you can go up this way. So it's actually branched. It's not one straight line, or it's not linear. And so since it's branch here, but it's the same thing in terms of the number of atoms, then this is an isomer, and so we call it isobutane. So if you notice, the number of carbons and hydrogen are the same, exact same thing, so the exact chemical makeup, but the structural arrangement is different, and so that is in an isomer. For a closed chain, it will look like this. There is no necessarily end, if you may. So notice all the carbons, they are joined together, forming a ring or a continuous pathway, which we call cyclic or closed. There is no opening at the ends. And this now is called cyclobutane. All right, and so I guess we have been through a number of concepts today, and I hope you appreciate the properties and concepts of writing alkanes. And so at this time, I want to tell you that I truly appreciate you watching. And I also want to tell you that everything in life is unique. And only if you could see how unique you are through God's eyes. So at this time, I want to say, have a blessed time. Keep safe until we meet again.